Um, Today we'll have a review of this Principle of Chemistry 1 ACS final exam. Now we have one from last semester, spring 2024. This is a review here for about one hour and a half or 2 hours. You can look into this here. We started math over the beginning of this. Those are similar to ACS exam. Now, if you scroll iCollege all the way down, you can see a lot of, in the folder area, you can see that's a lot of area you can go for this review. So you have this video, correct, and then you have ACS final exam review material. So those two folders have a lot of review material. So just open them and see if you can, if you have any question how to do those, and if the answer is not correct, just let me know. I'll be more than happy to help. So now there is two sessions here. I put them up now. I put them up time for the final exam. Put them all the way up, and I put this is again. This is another ACS exam with PowerPoint in each topic. So you can see I opened for the last one because the first one, those are covered inside the videos, the first and the second one. But the third one is the most difficult part, not this one here. Yeah, this one here. So let's look at the how those exams are, or how ACS questions looks like. Of course, they will give you some formulas, blank constant, Rydberg constant, gas constant. All those constants will be given to you, but real formulas will not be given. So it's 110 minutes, 70 questions. So I think you will be able to finish them on time. And if you have a problem with the time, do not spend your time on one question. If you think this question will take more time, skip it. Go for the one you can finish, and then come back to the last minute for the ones you are having problem with. Because if you're stuck in one, you cannot go nowhere, and you will be not able to finish the final exam. So let's look at those type of questions here. For example, this question, what you can tell about this question? What type of question is this? What type of the reaction? That's balancing chemical equation, but what type of reaction is this? It's not saying what balance, what type, but we can ask ourselves what type of question is this? This is what? No, we have 5 types. We have single replacement, we have double displacement, we have combination, we have decomposition, we have combustion, correct? We have redox reaction. So the redox reaction can have a big umbrella, can covers a lot of those single, except the double. Double is not redox. So this is a double displacement. If you look at this, sulfur here will take over. Sulfur will take over the sulfide, and the sodium here will take over the iodide. Double displacement. This is a double displacement. Now, let's balance this equation, and tell me how to balance it. We don't need a table here. We can balance it without a table. Since here the sulfur is 2 here, correct? So I put here 2, correct? And since sodium is 2 here, I put 2 here. And this is 1 and 1. Let's see. How many sulfur in the left? 2 sulfur atoms. How many in the right? 2. Sulfur is okay, correct. How many iodide? 2 in the left. And how many iodide there? 2 in the left, because the 2 is here. How many sodium? Sodium we say 2, and sodium here is 2. Sulfide is 1. Sulfide is 1. So the equation is 2 to 1, correct, to 2. Okay, the mole ratio or coefficient ratio is 2 to 1 to 1 to 2. What's the answer will be? The answer is B. Let's see if we have gotten this correct. Okay, we said this one B, yeah? So let's see here, the answer is here. The answer is what? Is B, correct. So now next, the limiting reactant for a given reaction can be recognized because it is the reagent that A, B, C, D, multiple choice. Which choice is correct? Which choice is correct? You read, has the smallest coefficient in the balance equation. That, of course, has nothing to do with the definition of the limiting reactant, correct? So that's not. Has the smallest mass in the chemical reaction mixture? No. Is present in the smallest molar quantity? Would be used up first. Molar, that's you cannot tell. Will be used what? Up first, correct? If you have two of reactants or more, and one is used up 100% completely out, that will be our limiting reactant. The excess reactant is a reactant that stays after the reaction is done. So, everybody's following? Yeah. Makes sense? That's the correct answer. The other ones had nothing to do with the limiting reactant stuff. So, let's take this one here, and let's see what the answer is. The answer is correct. Would be used up. So, now let's take another one. What type of reaction is this? What type of reaction is this? Combustion, correct. Pure oxygen as combustion, and which is part of the redox reaction, combustion reaction, okay? So let's tell me how we balance this. Again, there is no rule in balancing chemical equation. The main thing is we'll try to go trial and error until we get the number of moles at the left of the equation equal the number of moles at the right of the equation. So my intuition will tell me anytime I have an element by itself, I mean a molecule by itself, oxygen, nitrogen, I leave it at the end. If this nitrogen molecule or oxygen molecule or fluorine molecule by itself, keep it until the end, okay? So I have 7 carbons, so I put here 7. Make sense, guys? And I have 14 hydrogen, so carbon is okay, 7, 7. 14 hydrogen, I have 2. So I put what here? 7. 7 multiplied by 2, how much? 14. Makes sense? Everybody's following? Now the trick is I have 2 oxygens. Here's oxygen 2, and here's oxygen 2. This is 4 at the end. But here I have 7 multiplied by 2. 14 oxygen, correct? And 7 multiplied by 1 plus 7. This is 21. Okay, now, how in the world I will make this one here 21, the other side? Well, this is part of the molecule. I cannot control it. So this is 2. 21, I need what? 21, I need here to be what? 2, correct? So 2 minus 21. This is 2 here. So minus 2, I have how many left? 19, correct? Everybody's following? How about if I have here 19 and I have here, here's the 2 is there, so keep the 2 here. I'll put 19 over 2. Why 19 over 2? Because the 2 did cancel out. I have 19 oxygen, correct? And here's 221, which is 21 on the other side. Everybody's following why I put 19 over 2? Because I need the 2 here. Let's switch the color. I need the 2 here will cancel with the 2 here to get me 19. So I have here 19, correct? And here I have 2. When I add them up, I end up 21, which is equal to 21 the other side. This is two oxygens at the left. One is molecule, one is within the molecule. One is molecule by itself, one is within the two molecules. So now, I have 779 over 2, and I have this one here. Let me take this one here out. I say now, this is, we said 7, this is 1, it's 19 over 2, correct? Makes sense? We have 21 oxygen in the left, 21 oxygen in the 14 plus 7 is 21. So, nature will not support the 2 here, the fractional one. So I have to multiply the equation, the whole equation by 2, correct? So 2 C7H14O2 plus 19 over 2 multiplied by 2. The 2 cancels out. That's 19 O2 plus 2 multiplied by 7. This is 14 CO2 plus 2 multiplied by 7 is 14 H2O. Now let's check out if our work is correct. So now you tell me. Let's take another color. We have 2 multiplied by 7, carbon is 14. Correct, guys? 14, and here is 14. So carbon is balanced. Carbon is balanced. Let's take another one, another color. Let's take hydrogen. Hydrogen is 2 multiplied by 14, 28, correct? Everybody agrees? And here 14 multiplied by 2, how much? 28. So hydrogen is good. Hydrogen is good. Now oxygen is, we have to watch. Let's take another type of color. Let's take violet. 2 oxygen here. How many we have? Oops, sorry. Two multiplied by 2, how much is here? 4, correct? Everybody agrees? 4. And 19 plus 2, how much is it? 8. 38, is it? Everybody agrees? 19 multiplied by 2, how much? 38. 38 plus 4, oxygen is in both sides here. How much is it? 42, correct? Am I correct? Now, let's correct here, the whole thing here. 14 multiplied by 2 is what? 28. Correct? 14 multiplied by 2, 28. 14 multiplied by 1 is 14. How much is it? 42, correct? Everybody agrees on that? Correct? So the ratio is then 2, here it is, 2, 19, the more ratio or the coefficient ratio, 14, 14. Which is the correct one? Which is the correct one? A, B, C, D. Which one? Come on, guys. Which one? Today is what is today is Thursday, correct? Sounds like Monday today. Everybody's half asleep. Everybody's like half asleep. We have a lab, so we have to be ready for the lab. So guys, 2, 19, 14. Which option is this? Is this one here? That's what we have. Everybody agreed what we did? So let's see the answer. I did not see the answer. So let's take this one out and do the answer here. It is, the answer is, circle is what? 2, 19, 14, 14. That's correct. So now I will do something else. I will give you a couple, I will say a couple seconds, say a quarter minute or half a minute, 30 seconds. So tell me what's the answer here. What's the coefficient of sodium chloride when the reaction below is balanced with the smallest whole number coefficients? So we need to sodium chloride here. The question here, we need to know, whoops, sorry. Where is it? Yeah, we did that. Sorry about this. We need to know what is the coefficient here. So, can somebody will tell me? 30 seconds. You have the answer? What's the answer? 6. Okay, that sounds good. You think it is D. Okay, let's balance now the whole thing. Calcium is here 3, correct? So I put 3 here. So the chloride is 6. So I put 6 here. The phosphate is 2. I put 2 here. Sodium is 6 and phosphate is 2. It's balanced. So this is 3 to 2. This one understood, not written. 1 and 6. The answer is 6. That's correct. Everybody agrees? Everybody agrees? Okay, so that's the answer here, and we can check the answer here is, the answer is what? Circled. Can you see the circle here? There is circled is 6. The answer is 6 here. We can say this is 6. Coefficient in front of sodium chloride is 6. Okay, guys? We are doing good. We are doing good. So, let me just. So I think we will skip those. You know those balancing now. Everybody feels comfortable with the balancing. So we can skip because this is redundant. The same. It's not really difficult, but that's redundant. Or you want us to do this? We can do those. I mean, it's not difficult. This time we don't have oxygen, we have nitrogen. So we'll do this one and then we'll skip this balancing. So how many nitrogen we have here? 2. How many is here? 2. So nitrogen is 4 at the left. Here nitrogen is 2. So your intuition will tell you need how many? The first thing, put 2 here. Correct? And then you have 4 of your hydrogen, and we have here 2, put 2 here. Okay, guys? Now, by doing this, you have missed what? You have missed the oxygen. The oxygen is, we balance the nitrogen, oops, this is 2, and 2, 4, and the hydrogen is 4, 4, and the oxygen is 4 here. The oxygen is what? Is 2 here, so that's not correct. Everybody is following? We put this one here, 1, 1. That's not correct. Why it's not correct? Because the oxygen, that's the idea of trial and error. The oxygen in the right side is 2, but the oxygen here is 4. So what you can expect this one here to do? Somebody will tell me how to balance this? Any suggestion? So this is 2 nitrogen. This is 2 nitrogen. Nitrogen 4. We get the nitrogen 4 straightforward. So, however, the oxygen is for the other side. Okay. So, since I have a molecule here, that's your intuition will tell you that's not the right approach. What's the right approach will be? You think your intuition will tell you. This I'll keep it at the end because it's like oxygen staying by itself. I'll keep it at the end, and then I'll have to go through fraction and then balance the whole thing. So hydrogen is 4 here. I start with hydrogen. Hydrogen is 2 here, and oxygen is 4 here and 4. So put 4 here. Get the oxygen out of your way. So you have oxygen how many? 4, oxygen is good, oxygen is good. Anytime I have a molecule by itself, I keep it until the end. Oxygen 2, nitrogen 2, fluorine 2, chlorine 2, those are at the end. So start with the hydrogen. I put 4, so now the hydrogen is 8. So the hydrogen 4, then I put 8. Now how many hydrogen I have here? 2 and 2, 4 nitrogen. And here is 2. How many? 6. And here's 2. I put 3. So the answer is 2 to 1 to 3 to 4. So the nitrogen will be 3. Where is it 3? C? Is it C? The answer of nitrogen is C. Everybody is following? Everybody agrees on that? Everybody agrees? Okay, so let's take this one out. Yes, ask.
How come it's not 2?
What, 2?
Nitrogen also has 2 on the website.
No, nitrogen, you have 2 nitrogens. Here's a nitrogen, and here's a nitrogen. Make sense? We have started with it balancing.
The left side has more nitrogen.
No, but it has 6 at the end, but we have to balance it and add 3 here. Make sense? Here it is. Let's do it again. We said we keep the molecule by itself at the end. That's what it's asking for, nitrogen. But we have first to look at the oxygen here, 4. So I put 4 here to balance the oxygen here. That's the first thing, correct? So oxygen is balanced. Then I have 4 multiplied by 2, that's 8 hydrogen. But I have here 4, so I have to put 2 here in front to balance the hydrogen. Now, how many hydrogen in the left I have? 2 multiplied by 2, that's just 2. 2 multiplied by 2, that's 4. And here is 2. This is 6 at the left. However, here I have what? Only 2. So I multiplied this one by 3. So therefore it will be 2 to 1 to 3 to 4. Make sense? Okay, good. So the nitrogen will have value of 3. So let's see here. Can I take this one out? Can I take this one out? Okay, so we can check it out. The answer is what? The answer is 3. Make sense, guys? So you feel confident with those questions? Now, the only problem we have in this ACS exam or any standardized exam is the time. Those are timed questions which take a long time. So let's take another one. Now we are dealing, now it's different from balancing. Now we are dealing with stoichiometry calculations. So determine numbers of carbon dioxide burned with 2.45 mole. So here it is. We have to determine this, how many moles of carbon dioxide, correct? And it's given to you, you have 2.5 mole of ethanol, that's ethanol here, and you have 2.5 mole, correct? 2.5 mole ethanol. And you have excess. Now, when I say 2.5, that's excess, our limiting reactant is the ethanol. This is our limiting reactant. Okay, so you have an excess one and a limiting one. Okay, guys, so now you started with 2.5 mole of ethanol, correct? That's what I'm looking for, the moles of CO2 coming out. Well, always start whatever is given to you. Given to you is 2.50, that's 3 sig figs, mole of ethanol over 1. And then here you have we need to get from the equation what is the ratio of the ethanol there. So you have 2 here of CO2. So you have 2 mole of CO2, 2 mole of CO2 to 1 mole, understood, not written, to 1 mole of ethanol. Mole ethanol cancels out. 2 multiplied by 2.50, this is 0.005 mole. 3-sig fix, correct? 3-sig fix. Where is the answer here? The answer is correct. Everybody is following? 5 moles. So let's see if the answer is correct. So let's take this one out and see if this we have it correct. So this is the answer here of it, and the answer is correct. The answer is 5 moles. So this is the same thing. This is the same thing here. So what's the answer here? Somebody will tell me. What's the answer here? So you have how many moles of iron are necessary to react completely with 1.75 mole of oxygen gas. So we are relating our iron here. We don't know how many moles we need. We have this, the limiting reactant is oxygen is 1.75 mole. Okay, guys, so the same thing we did just a couple minutes ago. So you start whatever is given to you, 1.7 mole of oxygen, and then you do moles of oxygen, correct, to moles of iron. Iron is given to you, correct? So iron is, that's what you are looking for, iron. So you have iron is 4 moles, oxygen is 3. So this one cancels out, and then you have to multiply this by this divided by 3 to get the answer. The answer has to have 3 sigmas. So what is the answer here? Somebody will tell me. What's the answer here? A, B, C, D. Which one? Make your opinion. So
D.
What's that?
D.
D? No. What's that? Guys, look. This is I did not do any calculations. This is 2 multiplied by. That's what I was learned in Germany. Don't use calculator. So this is rounded to 2. 2 multiplied by 4, 8. 8 divided by 3 cannot be 3. It has to be 2 something, correct? So the answer is around 2 something. So 2 something. So the answer is correct when you write it there. So the professor does not require any calculator. So and prevented us from using calculator. So if you put 2 and something is, will tell you correct. That's correct answer. So where is the answer will be has 2 something. This one is not. This one is not. This one is not. The answer is this. Did I use a calculator? No. And let's see if I'm correct. I don't know. But that's what we have. We had a professor there in chemical engineering. He does not like the usage of calculators. He said calculators make the students, idle. Their brain, they don't think that much. But if you do for me, we just put the answer like this, and it's correct. And his questions, and answer exams, quizzes, all written. Does not believe in multiple choices. I said, I want to sit down and see if you really get the concept or not. It has a big, influence on us as a students when we are teenagers. After high school, it was very impressive. And I learned now. I do calculations. No calculator does not read. I need just to get where my value will be, and then my value has to be 2 something. See, and you put that like this. The answer is correct. So here it is. Let's take this one here. Let's see the answer here. What they have. The answer is correct. 2.33. So now you tell me about this. You have the molar mass of both, of oxygen and nitrogen dioxide, and it said what the mass of NO2 in grams, of course, formed by complete reaction of 2 moles of ozone, O3. O2 is oxygen, O3 is ozone, with excess of NO. NO, that's the excess, and ozone is limiting, so this is limiting. And this is excess. So, can I give you a couple minutes? Or 1 minute at least, guys? Can we? So start whatever is given to you. Given to you 2 moles of ozone. That's what you start. 2 moles of ozone 3. Now, you need the NO2. NO2 is the product, correct? So, moles of NO2 to mole of ozone. Because we're going to cancel ozone. So, look at this. What's the mole ratio? This is 1 NO2 and the mole of ozone, correct? So, moles of, that's ozone 3. This one cancels out, this one cancels out. Next, you need the molar mass. In order to get the grams of NO2, you need the molar mass. So they give you this molar mass to fool you. This is, you don't have to use. You have to use the second one. Multiplied by 46.0 gram NO2 per mole NO2. Mole NO2, the mole NO2 cancels out. Everybody's following? So, now, it's easy to find the answer. Do I need a calculator? No. 46 multiplied by, this is 92. How many sig figs we have? Give you 1 sig fix, correct? Well, it's 2 mole of oxygen. It should be 2.00 because their answer is in 3 sig figs. Well, they gave so the 2 mole is absolute value, so they put the according to 3 sig figs to the molar mass. That's correct. This is the 2 mole here. Absolute value is not part of the consideration. You just look at the those 3 sig figs. The answer is C. Correct? Everybody agree C? Okay, so let's see. The answer is C. Let's see. I know it's correct. The answer is C. Wow, very impressive. Now let's do this, the last one, and then we'll skip this. We'll go another topic of stoichiometry. So this is number of moles, number of grams. So I'll give you 1 minute to do it. So the reaction is balanced and given to you. And what's the mass in gram of ammonia necessary or needed to produce 0.340 mole of NO in presence of excess oxygen. So this is ammonia is limiting. Ammonia is limiting. Always visualize is, and this is excess. Okay, guys. So you start whatever is given to you. So where we start with? We start 0.340 mole nitrogen monoxide. I have to get mole NO at the bottom so I can cancel it out. Correct? So now what I need from there is given what's the mass of ammonia. Correct? So I have to have here mole of ammonia. This is 4 mole of ammonia, 4, and the nitrogen monoxide is 4, correct? And then I have to use, I need grams, correct? I need to use the grams from all those here. This is a trick. They give you all the molar mass, but you don't need. You need this for the ammonia. which is 17.03 gram ammonia per mole ammonia. So now cancel the units nicely. Mole NO with the mole NO cancels out mole NO3 and mole. So the only thing left is gram ammonia. So this is 1,1. This is 0.34, correct? So do I need a calculator? Well, I can need it, but I don't need to. This is 4 here. I'm telling you what I learned in the 70s. This is 4. If it's 5, will be 0.4. So I put this one 0.3. Are you following me? No calculator. And this is 3. This is, I watch for this. This is 17. So multiply this by 17. The answer is 21, 5, and 1. So it is 5.1. 5.1 something. Where is in the word 5 point something? 1 or something. Not 5.79, that's too big. This is not, this is not. So it has to be one of those two. But mine came with the approximation is 5.1. So which one will be our answer? What's that? You can calculate. Can you calculate how much is it?
It was C.
What's that?
It was C when I calculated.
You said C? Then I did a mistake then. Calculate 0.3 multiplied by 17. How much is it?
It was 5.7902.
0.3. If I put it 0.3.
5.7902.
5.7?
No, it's 5.1.
5.1, yeah.
Oh, I didn't do that math. I just multiplied 17.03 times 0.
Oh, it came C. It came C?
Uh-huh.
And they call the calculator. See, they should not put two numbers very close to each other. That's to fool this. I don't have a calculator. I estimated, my estimation came to this. But the calculator will give you this. Correct?
Yeah.
Now you have the opportunity to have a calculator, but they should not put those numbers very close to each other. So, but anyway, so the answer is according to the calculator, according to my humble, not my German professor. He died a long time ago. I finished the school in the 80s. He came closer, beginning of 90s. He died, but he put a lot of good impression on how to. Really very good idea. Chemical engineering was a difficult topic, but still he made it very simple. So this is, according to my estimation, came out to be this, and according to your calculation is C. We'll go by your calculator and let's see the answer is. Okay? But our setup is, the main thing is the setup is correct. Okay, guys? So, well, Ms. Martinez is correct. Your calculation is correct. Well, I estimated no calculator would be. So that's good. So now let's get out of this moles and let's do another topic. Let's do another topic because then we'll spend. This is the same thing, grams moles. This is grams moles, correct? This is grams moles. This is the same thing, guys. Grams moles, correct? No, this is different. This is different. This is Avogadro's. Remember Avogadro's?
Yeah.
This is different from whatever the mole and grams we have. This is Avogadro's, correct? Because whenever the point is, whenever we have the keyword atoms, molecules, ions are called formula units, then you have to use what? Avogadro's number. Somebody still remember Avogadro's number value? 1 mole, correct? It's atoms. The same thing here is molecules. Is the same value as ions or formula units. Okay, guys? Now this one here, you'll be astonished to see that the mole is a ratio, the same thing. So mass over what? Molar mass. So now you have the definition, fourth definition of mole. The mole is Avogadro's number of atoms, Avogadro's number of molecules, Avogadro's number of units, and its equal mass over molar mass ratio. So four definition of the moles. Four definition of the mole. So Avogadro's number of atoms, Avogadro's number of molecules, Avogadro's number of units, formula units or ions, and is the ratio between mass over molar mass. Correct, guys? So now let's look. Take this one out. Let's look at the question, what they ask, and let's answer it together. So, a self-contained breathing apparatus using potassium superoxide to convert carbon dioxide and H2O in exhaled air into oxygen. Well, you saw the military mask with the filter inside. That's what it said, self-containing breathing apparatus. There's a military mask to prevent if you have any for chemical warfares. You saw those in the movies and everything. So those they put potassium superoxide or magnesium oxide as well. They use oxides. So to convert the carbon dioxide and H2O in exhaled air into oxygen. This is the reaction there. That's the reaction there. How many molecules of oxygen gas will be produced from 0.0468 gram of dioxide exhaled in a typical breath in excess of KO2? So this is our excess reactant. This is limiting. Always remember this reactant, correct? Now you start whatever is given to you. They gave me this one here. So 0.0468 gram CO2. Now say how many molecules of oxygen, correct? Oxygen is my what? Product. I have to get the grams first into moles of CO2. So divide by the molar mass of CO2, which is given to me 44.01 gram of CO2 in mole of CO2. So with this in mind, I have gotten rid of gram CO2 with the gram CO2 out. Now I go for the equation and look how is my oxygen related to, that's the oxygen, correct? That's I'm asking for. I have 3 moles of oxygen 2, correct? That's here 3. And here the carbon dioxide is 4 to 4 mole of CO2. So then I can get rid of the mole CO2 with mole CO2 cancels out. Now, Avogadro's will come now in spiel. Then I have 1 mole of oxygen is 6.022 10 power 23 molecules, correct? Molecules O2. So this one here takes time for estimation, but how much is you think it will be? This is 3, this is 6 10 power 23. Keep the power by itself, don't touch the power, because you will see the power will come here by itself. Keep it at the end. See here the power? Keep the power at the end. First, you do those calculations. This amount here, multiplied by 3, multiplied by 6.02, divided into 44, and divided by 4. So how much is it? So we can see what's option we have. A, B, C, D. What do you think? So guys, so what's the value came out to be? Come up with the value, then you can see the exponent at the end, as ever end. Don't touch the exponent as yet, but just do the multiplication here and the division into those two numbers. The answer is A. Okay, so Ms. Martinez says A. It is A. Okay, so, well, I don't know. Can I check it out? Can I check it out? I'm checking this one out. And let's see here. Yeah, Ms. Martinez answer is correct. The answer is A. I did not calculate. I don't have a calculator. I can estimate. I will be off if they close to each other. No, that's a good question. They are not close to each other. 4.8 is far off from 8.5. 6.4 is far away from 1.9. Those type of, but if you put them very close, and the answer is A, and then I put for you 4.8, that's the answer, correct? But if I put one of the options 4.6, estimation will not work in this. Are you following me here? Because I will not be, that's close to estimate. Estimation is very crude number. It's not correct. So A is the question. So I think we'll go for further and see what we have here. And if that's the same topic, then we can, that's another topic. Theoretical yield, that's a good one. That's a good one. We are really progressing. That's very good. So what is the theoretical yield of NO, okay, of NO can be produced from the reaction 3.5 mole ammonia and 4.01 mole of oxygen. So what is the theoretical yield of NO that can be produced from reaction of 3.5 mole and ammonia? Ammonia is 3.5 O and oxygen is 4.1 mole. So what type of reaction is this? This type of reaction is limiting reactant. Because I don't know, every time I write you limiting and excess, they give us, but I don't know which is limiting, which is limiting, which is an excess. So theoretical yield, make a note for this. Theoretical yield calculation or calculations are based on all the times on limiting reactant calculation, limiting reactant calculations. So we have to do limiting reactants calculation. I don't know how much the whole thing is. So theoretical yield of NO. So let's do. Let's decide which one is limiting, which one in excess in those two reactants here. Okay. So that's what we will do. That's a good question. So let me take this one out. Can I take it out? Everybody has it. Everybody has it. Okay. So let's do this one here. First, we'll say, okay, let's look at number of moles of NO, the product here, based on, that's number one. You can do number of grams, but the same thing. Number of moles based on, first, ammonia, correct? See how many moles we have. Well, it turns out to be, you started with ammonia 3.5 mole. You started with 3.50 mole of ammonia, correct? Over 1 mole of ammonia here. And in the top is mole of your product in question, which is NO. NO is 4 in the top, at the bottom is 4. So the answer is 3.5. Okay, so this one here. This is 3.5. 3.5 mole NO. Okay, number 2. Now the second reactant, we'll see. Number of mole of NO based on oxygen, correct? That's the second one. So you start with how many oxygen is 4.01 mole of oxygen over 1 mole of oxygen to mole of NO. Mole of the oxygen is, you have here 5 mole of oxygen, 5, correct? And the NO is 4. So how much is it? 4 over 5 multiplied by 4, 16. 16 divided by 5, how much? 16, correct? Divided by 5 is 3 point something. 3 point what?
3.20.
20, okay.
3.21.
21, okay. So mole. 3.2. Now looking at this, which is limiting reactant, which is the smallest number of moles for NO based on oxygen and based on ammonia. This is 3.5. This is in excess. So this is more, correct? More. So this one will be excess reactant. This one will be consumed first because 3.21 is less than 3.50, correct? Makes sense? This is limiting. So we are basing the yield on this amount here. Now we need just the number of grams. This is number of mole. We need number of grams. So we'll have to, our NO, molar mass of NO, molar mass. Oh, we don't need the molar mass. Sorry about this. It's the answer given to us in multiple choice in moles. So the answer is 3.21. The answer is A. Thank you. The answer is A. The answer is A. Make sense, guys? The theoretical yield is always based, no exception, on the limiting reactant calculation. A limiting reactant, you take the product and then you base your number of moles of both products, and the least one will be limiting, the least one, 3.21. Okay, guys? Make sense? Everybody has this? Everybody has this? Okay, good. And we'll cover most of the stuff. I can promise you we'll cover a lot of stuff by the time we have the final. You get all this review, and you have a video there as well. So let's take this one here out. So the answer is A. The answer is A. So now, a mixture of 9 moles of fluorine and 4 moles of sulfur are allowed to react in this one here. How many moles of fluorine remains after 3 moles of sulfur have reacted? This is not a limiting reactant. This is a very tricky type of calculation. What's your answer will be? What do you think your answer will be? What's your answer will be? See, that's one of the instructors said, one of my friends instructor, she told me this is very tricky question, the students will miss it. So when I looked at it at the beginning, I missed it, then I looked at this without looking at the answer, I said, this is very funny thing. So look at this. This is a very funny type of, it will not come in ACS. This, I don't know who came up with this value here. So this is the product here. Sulfur hexafluoride, correct? Now, you have, out of this fluorine here, 9 moles, correct? and sulfur is 4 moles. Now let them react. How many moles of fluorine remain after 3 moles of sulfur is reacting? Correct? So after 3 moles of sulfur reacting, how many moles will be? What do you think? The answer is 0. See how tricky is this? You multiply the whole equation by 3. It says reacted by 3 more. Multiplied by 3, this is will be, then the equation will come out to be 9F2 plus 3S plus 3SF6. So you consumed all the 3 moles, and then left is 9, and you started with 9, so 9 minus 9 is 0 moles. So the answer is 0. Make sense? Does not make any sense. Yeah, that's type of a very tricky one. So you have to multiply the equation by 3. They did not give the answer of this, but they said the answer is 0. But that's really true, 0. But then I looked at the answer. You multiply the whole equation by 3 to get to the 3 moles that reacted, correct? So by doing 3S, then you have 9 flow. You multiply the whole thing by 3. You have 3 moles of the product, 9 fluorine. So then it started with 9, and then we used 3 of those. So then you have 9 and 9, 0 fluorine. So the limiting reactant is fluorine. It's limiting, correct? So now, can I take this one out? So the answer is, what is the answer? It's 0, correct? So the answer is 0. Don't ask me. This is a very tricky one. The whole thing is to add, multiply the whole equation by 3. And then 3 moles of sulfur will consume 9 moles of what? Of the fluorine gas. So the fluorine then 9 moles, start with 9 moles, so it will be 0 then at the end. Well, this is what is the maximum amount of ammonia can be produced when 0.23 moles of nitrogen with 0.9 mole of hydrogen. This is a limiting reactant calculations. I will skip it. You know how to do it, correct? I showed you with the NO. Everybody knows how to do it? Or you want me to do it for you? Do it?
Yes, please.
Okay, let's do it then. What's maximum amount of ammonia can be produced? This is our product. This is our product here. Now we don't know what's limiting reactant and which is excess reactant. We don't know, so we have to figure it out based on the product. We'll do the same thing. So number 1, number of moles of my products here, products ammonia, based on my reactant, the first reactant, based on nitrogen, correct? And the second one here, number of moles of my product based on the second reactant, which is hydrogen. So let's calculate, and then the least one said maximum amount. The least one will be our limiting, and then we base our calculation on this limiting reactant. Okay, guys? So let's do the first one. Let me change the color here, blue. So I have the based on ammonia on nitrogen. Nitrogen is 0.35. So 0.35 mole of nitrogen over 1 mole nitrogen in the bottom, 2 mole of ammonia at the top. That's the product. And I have 2 mole here of ammonia. 2 mole of nitrogen is 1. So this one here is 0.75 moles of ammonia. Correct, guys? of ammonia here. And the second one will be, I have based on the other is hydrogen, 0.90 mole of hydrogen to mole of hydrogen, correct? Mole of hydrogen, and to mole hydrogen. Hydrogen is then mole of ammonia in the top, the product. Then I have here 3, correct? This is 2, so 2 mole of ammonia, the product, to 3 mole of hydrogen. This one will be 2 multiplied by 0.9 divided by 3. How much is it, guys? How much is 0.6? 6 what? 0, okay, mole of ammonia. Now, which is limiting now, this or this? This is limiting, this is the least, correct? And this is what? This is the excess. The excess. And you look now, are they asking for the excess? This is excess. So look back on the question, see what's the maximum amount of ammonia that can be produced. Well, the maximum amount of ammonia will be what? Which one of those? Which one? What's that? Now, why you say B, not C? Why is not C? Why is not C? Well, the amount of the products are always based on what? On the limiting reactant, correct? Yes. So the limiting reactant is 0.6, and this is the limiting reactant, not on the excess. Okay, the 0.6 is correct. Okay, guys. So I think we'll skip this limiting type of stuff. We'll go for other stuff here. Is B, correct? That's another limiting reactant, guys. That's another one, correct? That's another limiting reactant. That's another limiting reactant. The answers are there, and everything in I college, all those in I college. This is combustion reaction, and again, this is another excess and limiting. I'll skip this one here. This is theoretical yield. We did that. I think it's now conceptual. This will come, guys, and you tell me about this type of. So, an initial reaction mixture of nitrogen. So nitrogen is the two ones. Nitrogen is the that's two molecule. Hydrogen is the darker one. Nitrogen, the non-dark one is hydrogen, and the product will be looking like this. Okay, guys? So which one of those, A, B, C, and D, will represent that will represent after the reaction is complete, present the products complete? Which one? So first, elimination. You have to learn something, process of elimination. The D, you have only ammonia. That's not true. You have excess reactant and limiting reactant. The one will be consumed is the limiting reactant, but you have excess and the product, correct? And this is, the reaction is, so I can eliminate this one out. Correct, guys? This by elimination. How about,
C has a funky,
what's that?
C.
C?
C has at the top, like, left corner.
This one here?
That, you can eliminate that one because that top left corner is a non key.
Okay, so what is about this is this one here, that you have hydrogen, you have nitrogen left, that's nitrogen here, and you have ammonia, correct? And you have 1, 2, 3, 4, 5 ammonia to how many hydrogens? To how many nitrogens? To 2, 1, 2, 3, to 3 nitrogens. Correct? You have to come, and then you have one is you don't know what that really is. That's NH. That's NH. We don't have NH. We have just ammonia there. Correct? So I can eliminate this. 2. Okay, guys. Now the question is there: this or this? This or this? Now let's count. You have to count them and see how the whole thing is looking for. So you have hydrogen here, hydrogen. So and then you have nitrogen. How many hydrogens do we have? 1, 2, 3, 4, 5. 5 hydrogen. How many nitrogen we have? 1, 2, 3, 4, 5. 5 nitrogen. How many reactants we have of ammonia? Only 1 ammonia came out to be, correct? So 1 ammonia. Everybody's following? So what do you think? Makes sense? Only 1 ammonia, and then most of those are it means this one here does not go to complete. Correct? 1 ammonia, and then you have 5 hydrogen plus 5 nitrogen. So does not make sense with the mole ratio here. Yeah. So it's not even it's the small amount of only 2, correct? So how about the other one? That will be the good representative of the whole thing, correct? According to whatever I said. So I don't some of their answers not correct, but anyway. So makes sense. You have to count. Here is just too many of the reactants and least of the product. The product is 2. However, the product is 2 mole and the nitrogen is 1 mole and 3 hydrogens. So hydrogen is 1, 2, 3, 4, 5. Nitrogen is 5. No, nitrogen has to be less a little bit, correct? Nitrogen has to be less a little bit. So let's see. Here it is. Let's look at the answer, guys. Where's the answer? The answer is A. Correct, guys? Makes sense? Now let's do the second one. The second one is challenging, guys. The second one is challenging. So, which one? You have oxygen. Now again, what you will do here, always count the mole ratio, 1 to 2 to 2. So which one I can eliminate at once? Which one I can eliminate at once? C I can eliminate? Yes, because it said just oxygen. I don't know, it's not giving me where it's not, there is no the other reactant. Okay, that's only oxygen. Where is, that's the product, correct? Product, that's the oxygen. But where is our fluorine? So I can eliminate this out. And this, can I eliminate it out? I can eliminate this out. Make sense? That's all of it products. Where is the excess? Remember, those reactions are, you have limiting, will be consumed, or small amount may be consumed, and you have excess. That's only the products. That does not represent the equation. So, will be this or this. Correct? So, well, this is not there. This is N, the fluorine, yes, product. So this one here, this one we don't have this N. This is 4 of fluorine. That's not 4 of fluorine here. That molecule does not exist. The molecule is here, correct, this which is NOFF, 2 fluorine atoms. So the only thing left is this. Because we don't have this type, I mean, this is fluorine, and then oxygen, oxygen. 4 oxygen, we don't have 4 oxygen, this is out. Okay? We don't have this, and we don't have those type of products. The type of products we have this one here. So F, and this is what we have. Something like this, but not 2 fluorine connected to each other. Oxygen has to be in the middle and the fluorine at the edge, because that's most electronegative one. So the answer will be B, correct? The answer is B, because you can't have fluorine. They will fight each other because there's the most electronegative element here. So I think the time is up. Yeah, the time is up. I will stop recording, and then we'll come. This is all the stoichiometry, and then we'll see to look on another one. Okay, guys, I'll stop.